Welcome to Tech Girl Kannada YouTube channel. Module 5 E-Waste Management. E-Waste Management Introduction, Sources of E-Waste, Composition and Characteristic of E-Waste, Effects of E-Waste on Environment and Human Health, Need of E-Waste Management, Recycling and Recovery Techniques, Different Approaches of Recycling, Separation, Thermal Treatments, Hydrometallurgical Extraction, pyrometallurgical methods, and direct recycling of e-waste, extraction of gold from e-waste, the role of stakeholders in environmental management of e-waste, producers, consumers, recyclers, and statutory bodies. E-waste management. Solid waste refers to all non-liquid garbage arising from animal and human activities that are discarded as unwanted and useless. It can be categorized based on materials such as plastic, paper, glass, metal, demolition materials, wood, pesticides, insecticides, and organic wastes. Based on the source, the solid waste can be classified into three types: electronic solid waste, e-waste, municipal solid waste, biomedical solid waste. E-waste can be defined as electronic and electrical equipment products that have become obsolete due to the change in fashion, style, status, and attaining the end of their useful life. E-waste management is the planned process of collection, transportation, and disposal of e-waste materials in safe, economic manner. Every day, tons of e-waste is disposing at various landfill sites and recycling units. E-wastes are considered dangerous as certain components of some electronic products contain materials like mercury, lead, antimony, phosphorus, etc., which are hazardous and pose threat to human health and environment. Sources: discard computers, televisions, VCRs, stereos, copiers, fax machines, electric lamps, cell phones, audio equipments, DVDs, CDs, washing machines, microwave ovens, motherboards, PCBs and batteries, etc. E-waste classification. The European Union directive divides e-waste into the following categories: the household appliances, refrigerators, freezers, washing machine, cloth dryers, dishwashers, vacuum cleaners, etc. Information and communication technology equipments, ICT, many computers, laptop, notebooks, printers, telephones, and cell phones. Consumer equipments, radios, televisions, audio video recorders, audio amplifiers, and musical instruments. Electrical and electronic tools, CFL tubes, incandescent lamps, LEDs, switches, drilling machine, sewing machine, grinding machine, etc. Toys and sporting goods, so electric trains or race cars, video games, sports equipment with electric elements. Medical devices, radiotherapy equipment, cardiology equipment, dialysis equipment, pulmonary ventilators, etc. Monitoring devices, smoke detectors, sugar detectors, heating regulators, etc. Automatic dispensers, or appliances that automatically deliver various products like ATM. Composition of e-waste. E-waste contains many components depending on the type of electrical device they contain. Valuable metals like gold, platinum, silver, palladium, etc. Useful metals like aluminium, copper, iron, etc. Hazardous materials like cadmium, mercury, arsenic, lead, radioactive substances, etc. Toxic substances like brominated flame retardants, dioxins, etc. Plastics materials like high-impact polystyrene, acrylonitrile, butadiene, styrene, ABS, polycarbonate, polyphenylene oxide, etc. Glass materials like cathode ray emission tube, transparent electrodes used in LEDs, glass made of SiO2, CaO, NaO, etc. For instance, cathode ray tubes found in televisions and computers contain lead, mercury, cadmium, gallium, and brominated flame retardants. A mobile phone, smartphone contains more than 50 different components, including base metal, copper, and special metals, cobalt, indium, antimony, and precious metals, silver, gold, palladium. The lithium-ion battery contains about 3.5 grams of cobalt. Iron and steel constitute about 50% of the waste, followed by plastic 21%, non-ferrous metals 13%, and other constituents. Non-ferrous metal consists of metals like copper, aluminium, and precious metals like silver, gold, platinum, palladium, and so on. Characteristics of e-waste. Information and data on characteristics of e-waste are important for selecting a suitable disposal technique. Hazardous materials. Electronic waste consists of large amount of components, some of which contain hazardous materials. Example, flame retardant used in plastic, non-biodegradable materials like PVC, PV, HGCD, etc. If not properly disposed, these substances can harm human health and environment. Non-hazardous materials. E-waste contain valuable metals like iron, copper, aluminium, and noble metals like gold, silver, platinum. They also need to be separated by proper recycling methods before discarding the e-waste to save natural resources. Rapid obsolescence. Some electronic devices obsolete quickly and contribute to the e-waste stream, so care to be taken while discarding such devices. E-waste disposal methods. All electronic waste is made up of deadly chemicals such as lead, cadmium, beryllium, mercury, and brominated flame retardants. Improper disposal of e-waste increases the chances of dangerous chemical containing the soil, polluting the air, and leaching into water bodies. So care to be taken while disposing e-wastes. There are various methods available for the disposal of e-waste to minimize pollution. Landfills. It is the most common and oldest e-waste disposal method, where waste is directly disposed into a large pit or trench and is covered with a thin layer of soil. The pits are lined with clay or plastic with a leachate basin to prevent the leaching of toxic wastes into the surrounding environment. Note: Narela Bhavana in New Delhi is the only scientific landfill in India. It has the capacity to treat 2000 megaton of waste every day, generating 24 megawatts of electricity. Recycling is the process of taking useful things from the discarded items for next use. Before recycling, separate the materials like paper, glass, plastic, metal, rubber, etc. from waste. Primary recycling involves procession of waste scrap into materials that have characteristics similar to those of original materials. Example, remolding of plastic, recovery of valuable metals. Secondary recycling involves processing of waste or scrap into materials that have characteristics different from those of original material. Organic waste is used for making compost, which can be used as manure. Tertiary recycling involves the production of basic chemicals and fuels from plastic wastes using the suitable chemical process such as pyrolysis. Third one is reuse. This is the most environmental friendly e-waste disposal technique where possible components of the e-waste can be reused. Plastic jars or jam, pickles, oil, etc., which are in good condition, can be used for storing salt, spices, sugar, etc. With slight modification. The mobile phones, computers, laptop, printers can be reused or given as a second-hand product to the other person. The old electronic equipment can also be donated to the various charity programs and thus helping the person in need. Incineration. The process is usually selected to treat the wastes that cannot be recycled, reused, or disposed in landfills. It involves the burning of e-waste in an incinerator unit at around 900 degrees Celsius to 10,000 degrees Celsius until the wastes are turned into ashes. It reduces the volume and weight of the waste for safe disposal of in the outer landfills. Also, heat energy released during burning can be used to generate electricity. Toxic materials used in manufacturing electrical products. Electronic and electrical products contain a number of hazardous substances, including mercury, lead, cadmium, hexavalent, chromium, barium, lithium, arsenic, polybrominated biphenyls, polybrominated diphenyl ethers, glass, plastic, softeners, adhesives, etc. Effects of toxic materials present in E-waste. Long-term exposure to e-waste cause health and environmental problems. Electronic waste contains toxic components such as mercury, lead, cadmium, polybrominated flame retardants, dangerous to human health. They damage brain, liver, kidney, heart, reproductive systems of the human body, and skeletal system. Exposure to lead from e-waste recycling activities causes hyperactivity disorder, behavioral problems, and changes in child temperament. Fumes released during burning of insulated wires and cables to obtain copper causes neurological disorders and cancers. Acute exposure to cadmium found in semiconductors and chip resistors can damage the kidneys and liver. Long-term exposure to lead found in printed circuit boards, computers, and television screens can damage the central peripheral nervous system and kidneys. Informal disposal of e-waste releases dust particles of heavy metals and flame retardants into the atmosphere. This causes air pollution. Improper disposal of the e-waste in regular landfills or in places where it is dumped illegally. Both heavy metals and flame retardants can seep directly from the e-waste into the soil, causing contamination of the soil and groundwater and crops that are planted nearby. The entry of acids from the e-waste into the water increases its acidic nature, which can kill the marine and freshwater organisms, disturbing the biodiversity and harm ecosystem. The improper burning of the e-waste releases harmful hydrocarbons which can contribute to the greenhouse effect. Lead, mercury inhibits the production of hemoglobin, causing anemia and decrease the oxygen carrying capacity of the blood. Need of e-waste management. A planned process of collection, transportation, and disposal of the e-waste in a safe and economic manner is called e-waste management. This helps to reduce landfill sites. The more we recycle, the less waste we generate, which applies to all kinds of waste. So recycling reduces the usage of land for landfills, reduce landfill sites, allow more land to be utilized for more purposes such as agricultural, housing, development, etc. Preserve natural resources. Recycling helps to recover valuable materials from e-waste, which can be used to produce new materials. This saves and conserves natural resources. This way, manufacturers do not need to mine the minerals. Instead, they can recycle, reuse the components of e-waste. Thus, it promotes the utilization of resources wisely. Prevent toxic chemicals from polluting the ecosystem. Electronic components contain a number of toxic chemicals such as nickel, cadmium, lithium, mercury, and lead. During burying e-waste in landfills, these toxic chemicals leach into our soil, waterways, and ecosystem, causing long-term damage to our health and environment. This can be prevented by proper recycling of e-waste. Reduce manufacturing cost. Components obtained from recycling of e-waste are cheaper than those obtained from mining activities. Therefore, the usage of recycled components in the manufacturing of new materials reduces the manufacturing cost. Prevent environmental issues. E-waste contains hazardous materials that can contaminate the soil or air or water, posing severe health risks to human and animal life. The proper disposal of e-waste reduces environmental problems. Prevent loss of data. Secure disposal of the e-waste prevents the loss of data. Reduce energy consumption. Energy required to recover valuable metals from e-waste through recycling is lesser than the energy required to extract metal from their ones. So, energy consumption and green gas emission can be reduced. Reduce legal complications. A proper management of e-waste reduces the legal complications arises between stakeholders and government. Recycling of e-waste. E-waste recycling is the process of extracting valuable materials from waste. A basic flow sheet diagram of recycling is shown below. It consists of three main steps: collection and sorting, pre-processing, and end processing. Each step is critical for the recovery of metals. The first step involves sorting of components and unwanted or useless electronic materials. The expired equipments are manually dismantled at collection facilities, and individual components are tested and isolated from e-waste. At this stage, housing, wiring boards, drives, and other components are to be separated. If these parts are still functional, they can be used by for building new products. Reprocessing of e-waste is one of the most important steps in the recycling process. Mechanical processing is an integrated part of this stage where e-waste scrap is shredded into pieces using hammer mills. Then metals and non-metals are separated during this stage using techniques like screening, magnetic separation, eddy current, and density separation techniques. Ferromagnetic materials like iron and steel are separated using magnetic separator. Paramagnetic materials like copper, aluminium, etc. are separated using eddy current. The other non-magnetic material like plastics can be separated by density separation method. This process is at most important as the waste contains hazardous materials and must be performed by skillful workers. Sorting and dismantling, separation of reused parts, mechanical processing, size reduction plus manual sorting, separation of wirings, metals, plastic, vibrating screen, density separation, separation of plastics, magnetic separation, separation of ferrous metals, eddy current separation, separation of non-ferrous metals, disposal, landfills. The final stage in the recycling is the end processing, where the non-metal and metal fractions of e-wastes are further processed for recycling and utilization. Metallic fraction of e-waste can be further processed to separate or extract minor metals elements using various metallurgical processes and utilized for manufacturing new products and equipment. The non-metallic fraction of e-waste wasted PCBs contain more than 70% of non-metallic fractions are recycled and utilized for the production of new substances. Example are non-metallic composite plate produced using pulverized PCBs combined with CaCO3, unsaturated polyesters, polystyrene, glass fiber, zinc, stearate, and pigments process comparable mechanical properties to those of plastics. Other recycling routes of non-metallic PCB materials are based on chemical processes that include gasification, pyrolysis, and supercritical fluid depolymerization for producing chemical substances and fuels. Finally, the residues is subjected to safe disposal at landfills. Extraction of metals from e-waste. There are several methods known to extract metals from e-waste. Pyrometallurgy. It is widely used for recovery of precious metal from e-waste. Biohydrometallurgy. It is majority used to extract metal from metallic sulfides. Hydrometallurgy majorly applied to recover
Noble metals from e-waste, it is more promising technology due to its low cost, high selectivity and lower environmental impact. Direct recycling, it's a promising low energy consumption, environmental friendly and more efficient method. Steps involved in pyrometallurgy method. Pyrometallurgical treatment for extraction and recovery of metals is done for the past 2 decades. Here the precious metals and base metals are separated by eliminating the organic substances and plastics. The treatment is done at the extreme temperature of 600 to 1200 degrees Celsius in combustion, where the sintering, melting, and reactions in the gas phase occur. Currently, this is the most used route for e waste recycling. The steps involved are as follows: collecting and sorting. Collect the e waste containing valuable metals like copper, lead, zinc, etc., and sort out to isolate components suitable for pyrometallurgical processing. Shredding. Grind the sorted e-waste mechanically to reduce their size and enhance surface area. Separation. Separate ferrous, non-ferrous metals and non-metals from the mixture by magnetic eddy current density separation method. Smelting. The metallic mixture is then fed into the blast furnace and subject to high temperature over 1000 degrees Celsius. During smelting, the e-waste materials melt and metal rich components fused together to form a molten mass of called matte settling. The matte being denser than slag, a less valuable byproduct formed during smelting, settles at the bottom of the furnace due to its high density. Blow air. Molten matte from the smelting furnace is poured into the converter, after which air is blown to oxidize iron and sulfur. Sulfur goes off as sulfur dioxide gas and iron as iron oxide slag. Copper converts into blister copper. Removal. Once the matte has settled, remove it from the bottom of the furnace and collect it under further processing. Refining. It involves the recovery of high purity metals from the matte. Fire refining. In this method, metals present in matte are recovered in pure form by fractional distillation. Example: if matte contains zinc, cadmium, and lead, lead boils at 1744 degrees Celsius, zinc at 907 degrees Celsius, and cadmium at 765 degrees Celsius. In the first stage, zinc cadmium are boiled off, leaving liquid lead, and in the second stage, cadmium is boiled off to leave high purity zinc metal. Electro refining. The method gives the highest purity as well as the best recovery of valuable metals. The impure metal is made as anode of an electrolytic cell, and cathode must be pure metal and immerse them in an electrolyte. When electricity is passed through the cell, metal ion dissolve from the anode and deposit on the cathode. The insoluble sludge left in the cell is treated to recover any valuable byproduct metals. Slag processing. This slag, which contains metallic, non-metallic components and other impurities, is further processed to recover any valuable material or for safe disposal. Collection of metal. The metal obtained after refining is collected in a suitable form for use in various industries. Pyrometallurgical recycling method is commonly used for metals like copper, lead, zinc, and iron. However, it may not be suitable for certain precious metals like gold, which requires different extraction process due to their high values and lower abundance in e-waste. Limitations of pyrometallurgical process. Pyrometallurgical routes are generally more economical, eco-efficient, and maximize the recovery of PMs. However, they have certain limitations. Iron and aluminium recovery is not easy as they end up in the slag phase as oxides. Hazardous emissions such as dioxins are generated during smelting of feed material containing halogenated flame retardants. A large investment is required for installing integrated e-waste recycling plants and that maximize the recovery of valuable. Instant burning of fine dust of organic materials, non-metallic fractions of e-waste can occur before reaching the metal bath. Ceramic components in feed material can increase the volume of flak generated in the blast furnaces, which thereby increase the risk of losing valuable metals. Partial recovery and purity of valuable metals are achieved by pyrometallurgical routes. Therefore, subsequent hydrometallurgical and electrochemical techniques are necessary to extract pure metals. Steps involved in hydrometallurgical process. In this process, the targeted metals are leached into solution of desired concentration using strong acid or alkalis. Generally, H2O2, HNO3, NaOH, H2SO4 are the solvents used for leaching. After the extraction of metals, they are connected by using various methods like cementation, solvent extraction, chemical reduction, precipitation, and ion exchange process. These methods are more preferable than pyrometallurgical process because of the more extract recovery of precious metals, predictable process, and can be controlled easily. Collection and sorting. Collect the e-waste containing valuable metals like copper, lead, zinc, gold, etc. and sort out to isolate components suitable for hydrometallurgical processing. Shredding. The sorted materials are crushed and grinded into smaller particles to increase the surface area for efficient chemical reactions. Separation. Separate ferrous, non-ferrous metals and non-metals from the mixture by magnetic, eddy current, and density separation methods. Leaching. The separated metallic mixture is mixed with a suitable leachant like acids, bases, aqua regia, cyanide, thoria, halides, etc. to create a leach solution. Filtration. Some metals dissolve in leaching solution and remaining metals settle at the bottom of the vessel. Separate the residue and solution through filtration. Concentration. Concentrate the solution containing metal ions of interest to increase their content in the solution and make subsequent processing more effective. Precipitation. Precipitate the concentrated metal ions to form a solid metal compound using a suitable precipitating agent. Drying and calcination. The obtained metal compound is subjected to drying and calcination to recover the metal. Example: if a metal is less reactive than carbon, it can be extracted from its oxide by heating with carbon. Carbon displaces the metal from metal oxide by removing oxygen. This leaves the metal. Electrowinning. In some cases, an electric current is passed through the electrodes dipped in solution containing metal ion of interest to deposit the metal on cathode surface. Here, anode must be inert electrode and cathode must be pure form of metal to be recovered. Limitations of hydrometallurgy process. Hydrometallurgical routes have been successfully used to recover PMs from e-waste. However, these processes are associated with certain disadvantages that limit their application on industrial scale. Overall, hydrometallurgical routes are slow and time consuming and impact recycling economy. Mechanical processing of the e-waste takes longer to reduce size for efficient dissolution. Cyanide is a dangerous leachant and should therefore be used with high safety standards. It can cause contamination of rivers, seawater. Halide leaching is difficult to implement due to strong corrosive acids and oxidizing conditions. The use of Thauria leachants is limited in gold extraction due to its high cost and consumption. There are risks of valuable loss during dissolution and subsequent steps. Steps involved in direct recycling. It is a promising, low energy consumption, environmental friendly, and more efficient method. Normally, it is used in the recycling of batteries. Recycling of lithium ion battery by direct method is explained as follows. Direct recycling of lithium ion battery. It includes discharging, extraction of electrolyte, deassembling, crushing, screening, magnetic separation, froth, flotation, cathode healing, and finally building new cells with recycled cathode and anode. Direct recycling process. End of the life of the batteries, battery use, electrolyte recovery, battery shredding, cathode anode separation, cathode black and PVDF removal, relithiation, battery manufacturing, battery use, end of battery life, discharge, and electrolyte extraction. To reduce the risk of explosion, combustion, and poisonous gas release during recovery process, spent LIBs need to be discharged before recycled. Discharge the lithium ion cells using sodium bicarbonate brine solution. Extract the electrolyte from battery using liquid carbon dioxide. Separation of materials. After removing the electrolyte, deassemble the cells, remove polymer separators, then crush anode cathode cells into powder and separate cathode carbon black binder PVDF anode or cathode current collectors. Copper and aluminium and anode cathode active materials, graphite and metal oxide. Remove binder and carbon black using solvents and dimethyl sulfoxide, thermal or mechanical methods. It must be performed in a controlled manner through thermal decomposition at 800 degrees Celsius without any additions. Separate copper and aluminium with a recovery rate of 92% and 97% respectively using pneumatic separation method. Separate graphite and metal oxide by froth flotation process. Place a mixture in a vessel and add surfactant. The mixture is agitated for 15 to 20 seconds to achieve a visible separation of carbon, float, and metal oxide zinc. decant the float immediately. The metal oxide settle under gravity, is collected and dried under vacuum. Cathode healing or re-lithiation. After separating the cathode material metal oxide, it should be re-lithiated hydrothermically by keeping the cathode in a sealed pressure vessel with a saturated aqueous lithium hydroxide solution. After hydrothermal treatment, remove the electrode material from the vessel and rinse with deionized water. Then heat the cathode under air to 800 degrees Celsius. Reassembling of the cell. Construct new lithium ion cell using recycled rejuvenated lithium metal oxide. Cathode coated aluminum current collector and graphite anodes coated on copper current collector. The electrodes were stacked alternatively and separated by porous polyethylene separators. The electrolyte LiPF6 in ethylene carbonate, ethyl methyl carbonate was imbibed into the cell and sealed. The fully assembled cells develops a potential between 3 to 4.2 volts. Extraction of gold from e-waste. Hydrometallurgy has gained importance all over the world, and majority of the construct new Li-ion cells using recycled rejuvenated lithium. Extraction of gold from e-waste. Hydrometallurgy has gained importance all over the world, and majority of the gold extracting from e-waste is by this method. Steps involved in the process are dismantling and collection and dismantling. Collect the e-waste containing gold and dismantle all the components. The individual components are tested for gold content and isolated. Grinding. Grind the isolated component containing gold to pieces of size 1 to 2 mm. Mechanical separation. Separation metallic and non-metallic materials by density separation method. Then separate magnetic and non-magnetic materials using eddy current. Leaching and nitric acid. Leach the non-magnetic materials in concentrated HNO3 65% for about 1 hour to remove the metals like Cu, Ag and Pb and decant the solution. Leaching in aqua regia. Leaching. Leach the residue of aqua regia solution, that is HCl HNO3 3:1 by volume, so that the gold particles dissolve in aqua regia. The reaction releases bubbles followed by sublimation of NO2 gas. The solution is then decanted and the pieces were subsequently washed with 10 ml of concentrated HCl so that all the gold content is fed into the solution. That is AU plus 3HNO3 plus 4HCl gives AuCl4 minus plus 3NO2 plus H3O plus 2H2O. Au plus HNO3 plus 4HCl, AuCl4 minus plus NO plus H3O plus H2O. Removal of excess nitric acid. Sulfuric acid is added to the solution to accelerate the removal of nitric acid and sedimentation of lead as lead sulfate, if any, and decant the gold solution after 45 minutes. Gold precipitation. Add iron sulfate for 0.2 gram of gold solution slowly to the gold containing solution to precipitate the gold. Allow the solution to stand so that gold settle down the bottom. Washing and purifying the gold deposit. Wash the gold deposit with HCl to ensure the cleanness of the gold. Finally, the precipitate is filtered. Wash it with large amounts of warm water and dried in an oven at 100 degrees Celsius. The role of stakeholders in e-waste management. Stakeholders such as producers, consumers, recyclers, and statutory bodies play essential role in the management of e-waste to ensure environmental sustainability and proper waste disposal. Producers, manufacturers, and producers are responsible for designing electronic products that must be eco-friendly. Their role involves incorporating eco-friendly materials, prompting product durability, and implementing take-back programs to ensure responsible disposal and recycling of useless electronics. Consumers. They are significant stakeholders as they generate e-waste through the disposal of old electronic devices. Raising awareness among the consumers about the importance of the recycling, encouraging proper e-waste disposal, and participating in recycling programs are vital steps in effective in waste management. Recyclers. There are 4 print offers management responsible for processing and recycling disordered electronic. Recyclers extract valuable materials and dispose hazardous substances in an environmentally friendly manner. Proper recycling prevents, reduces the use of land or landfills and contributes to resource conservation. By collaborating and fulfill their respective responsibilities, these stakeholders can contribute to sustainable e-waste management. Statutory bodies. Policy formulation. Statutory bodies formulate laws and regulations that govern the proper handling, disposal, and recycling of electronic waste. These policies outline the responsibilities of various stakeholders such as manufacturers, consumers, and recyclers. Enforcement. These bodies are responsible to ensure that the established e-waste management working properly. They must do inspections, audits, and investigations to identify and penalize any violations or non-compliance with e-waste laws. Licensing and permit. Statutory bodies often issue license or permits to the individuals organizations involved in e-waste management. These licenses must ensure that whether the individuals or organizations are following the standards and requirements set for safe e-waste management. Monitoring and data collection. These bodies monitor the generation, collection, transportation, and e-waste disposal of e-waste by collecting data on e-waste quantities and disposal methods. They can access the effectiveness of the regulations and make informed decisions for improvements. Awareness and education. These bodies create awareness about the ill effects of improper e-waste disposal and the benefits of recycling. They conduct campaigns, workshops, and educational programs to educate the people about proper disposal and recycling of e-waste. Educational programs to educate the people about proper disposal and recycling of e-waste. Innovation and research. They must support research and innovation in e-waste management, technology, and process. This can lead to the development of more efficient recycling methods and strategies to minimize environmental issues. Crisis management. In the event of e waste related emergencies such as spills or accidents during transportation or handling, these bodies coordinate responses to avoid environmental and health risk. Question bank. Mention the sources of e waste and explain the need for e waste management. Explain the recycling of e waste. Explain the extraction of gold from e waste. Explain the ill effects of toxic environment materials used in manufacturing electric and electronic products. Explain the steps involved in pyrometallurgical recycling. Describe direct recycling method. Illustrate the steps involved in hydrometallurgical recycling process. Write a brief note on the role of stakeholders, for example, producers, consumers, recyclers in e-waste management. Discuss the role of statutory bodies in the e-waste management. Thank you for watching. Do like, share and subscribe to my channel.